The latest generation of Chinese weapons seen on display, designed to win any future conflict.
A new generation of Chinese weapons is drawing serious attention around the world. Hypersonic glide vehicles, long-range nuclear missiles, cyber warfare units, and electromagnetic aircraft carriers are no longer ideas on paper. They are active systems. What makes these weapons so difficult to counter? And why are military analysts paying close attention now? Join us as we explore each one carefully. Number 10. YJ-18 Anti-Ship Cruise Missile. The YJ-18 is a long-range anti-ship cruise missile used by the Chinese Navy. It is designed to be launched from both surface warships and submarines. This flexibility allows it to operate from destroyers such as the Type 052D and from Yuan-class diesel-electric submarines. Because it can be fired from different platforms, it increases tactical options at sea. The missile uses a two-stage flight profile. In the first stage, it travels at subsonic speed. This slower speed helps it conserve fuel and extend its range. It also reduces heat and radar signature during most of its journey. The estimated range is over 500 kilometers. This allows a ship or submarine to strike from a significant distance. As it approaches the target, the second stage begins. The missile accelerates to roughly Mach 2.5 to Mach 3. This sudden speed increase happens during the final phase of flight. At the same time, it drops to a very low altitude above the sea. This is known as sea skimming flight. Flying just meters above the water makes radar detection more difficult because sea clutter interferes with tracking systems. The YJ-18 can also perform terminal evasive maneuvers. It may change direction slightly during the final approach to complicate interception. Some versions are believed to use data link updates while in flight. This allows course correction if new targeting information becomes available. Compared to older anti-ship missiles such as the American Harpoon, the YJ-18 has a longer range and a supersonic terminal phase. The Harpoon remains subsonic throughout its flight. The combination of long reach and late-stage acceleration gives the YJ-18 a shorter reaction window for defending ships. Modern carrier strike groups rely on layered defenses that include radar, interceptor missiles, and close-in weapon systems. A missile that approaches low and accelerates late reduces the time available for those systems to respond. But what happens when a missile does not skim the sea at all and instead descends from above at hypersonic speed? Number 9. DF-17 Hypersonic Glide Vehicle System. The DF-17 is a medium-range ballistic missile system that carries a hypersonic glide vehicle. It was publicly displayed during China's National Parade in 2019. Unlike a traditional ballistic missile, this system does not rely only on a fixed arc through space. Instead, it deploys a maneuverable glide vehicle after launch. A normal ballistic missile rises high into the atmosphere, follows a predictable path, and then falls toward its target. Its warhead re-enters at high speed, but follows a largely fixed trajectory. The DF-17 works differently. After the booster rocket lifts the vehicle to high altitude, the glide vehicle separates. It then re-enters the upper atmosphere and begins gliding toward its target at hypersonic speed, meaning above Mach 5. During this glide phase, the vehicle can maneuver. It can adjust direction and altitude while traveling at very high speed. This makes its path less predictable than a standard ballistic warhead. It also flies at a lower altitude than intercontinental ballistic missiles, which usually travel through outer space before re-entry. Because of this lower flight path, some early warning radars may detect it later compared to traditional long-range ballistic missiles. Operating at hypersonic speed creates intense heat. The glide vehicle must use advanced thermal shielding to survive atmospheric friction. Materials designed to resist extreme temperatures protect internal guidance systems. Aerodynamic control surfaces allow it to steer during flight, despite the stress of high-speed airflow. The DF-17 is believed to be operated by the People's Liberation Army Rocket Force. Its range places it in the medium-range category, meaning it is intended for regional targets rather than intercontinental distances. Compared to a conventional ballistic warhead, the hypersonic glide vehicle adds maneuverability during the final approach. This complicates interception because defense systems must account for possible changes in direction. If maneuvering hypersonic weapons are difficult to stop, what about missiles that can carry multiple warheads to multiple cities at once? Number 8. DF-41 Intercontinental Ballistic Missile. The DF-41 is one of China's most advanced intercontinental ballistic missiles. It is designed for very long distances, with estimates placing its range between 12,000 and 15,000 kilometers. This range allows it to reach targets across continents. One important feature of the DF-41 is that it is road mobile. It is carried on a large transporter erector launcher vehicle. This vehicle can move across highways and prepared roads. Mobility makes it harder for satellites to track exact launch locations. Instead of being fixed in underground silos, the missile can be relocated and hidden. The missile uses solid fuel. Solid-fueled missiles can be stored ready for launch without lengthy fueling procedures. This reduces preparation time compared to older liquid-fueled systems. Faster readiness improves survivability in a crisis situation. The DF-41 is also believed to support MIRV technology. MIRV stands for Multiple Independently Targetable Reentry Vehicles. This means a single missile can carry several warheads. After the missile reaches space, these warheads separate and travel toward different targets. Each warhead can be guided independently. This increases the number of targets that can be struck with one launch. The missile is part of China's nuclear triad modernization. A nuclear triad includes land-based missiles, submarine-launched missiles, and strategic bombers. Strengthening the land-based leg provides balance within this structure. Because the DF-41 can move, and because it carries multiple warheads, it presents tracking and interception challenges. Its mobility complicates surveillance, while MIRV capability increases the complexity of missile defense planning. But nuclear deterrence is not only land-based anymore. What if retaliation could disappear beneath the ocean? Number 7. Type 09 Forajin-class nuclear submarine. The Type 094A is a nuclear-powered ballistic missile submarine. It belongs to the Jin class and represents a key part of China's sea-based nuclear deterrent. As a nuclear-powered vessel, it can remain underwater for long periods without surfacing for fuel. This endurance allows it to patrol distant waters. The submarine carries the JL-2 submarine-launched ballistic missile. The estimated range of the JL-2 is between 7,000 and 8,000 kilometers. This allows the submarine to remain at sea while still holding distant targets within reach. Each submarine can carry multiple JL-2 missiles in vertical launch tubes. The sea-based leg of a nuclear force is important because it increases survivability. Submarines are harder to detect than fixed land installations. If land-based systems were compromised, submarines at sea could still respond. This concept is known as second strike capability. It is meant to ensure deterrence by maintaining the ability to respond after an attack. The Type 094A is considered an improved version over earlier Type 094 submarines. Reports suggest noise reduction measures have been added. Quieter operation improves stealth and reduces the chance of detection by anti-submarine forces. Strategic patrol patterns often focus on areas within reach of protected waters, including parts of the Western Pacific. By operating in areas supported by friendly naval forces, the submarine can enhance its security. The combination of nuclear propulsion, long-range missiles, and extended patrol endurance makes the Type 094A an important element of China's strategic forces. But China's modernization is not limited to missiles. Some of its most disruptive systems never even carry a nuclear warhead. Number 6. LY-1 Laser Air Defense System. The LY-1 is a ground-based laser air defense system developed in China. It is designed mainly to counter small unmanned aerial vehicles and low-flying drones. These targets are often difficult to intercept with traditional missiles because they are small, slow, and inexpensive. Using costly interceptor missiles against them is not efficient. A laser system offers a different approach. The LY-1 works as a directed energy weapon. Instead of firing a physical projectile, it emits a concentrated beam of energy. When this beam stays focused on a target for a short period, it can damage sensitive parts, such as sensors, control surfaces, or propulsion systems. This can cause the drone to lose control or fall from the sky. The reported effective range is about 4 kilometers, depending on weather and visibility conditions. One important feature is silent operation. A laser beam does not create the same noise as a missile launch or gunfire. There is no visible smoke trail, and there is no explosive impact. This makes the system less noticeable during operation. Another advantage is cost per shot. Once the system is powered, each firing cycle mainly consumes electricity. This is generally far less expensive than launching a guided missile. However, laser weapons have limitations. They require a clear line of sight. Obstacles such as buildings, hills, or thick smoke can block or weaken the beam. Weather conditions like heavy rain, fog, or dust can reduce effectiveness because particles in the air scatter energy. Continuous operation also produces heat inside the system. To maintain performance, cooling systems are necessary. These systems remove excess heat from the laser components to prevent damage. Power supply is also critical. A stable and strong energy source is required to generate a high-energy beam. For ground-based units, this usually means integrated power systems or support vehicles. The LY-1 reflects a shift toward countering modern aerial threats with precision energy instead of traditional ammunition. If lasers defend the skies, what protects warships from missile swarms at close range? Number 5. H/PJ-17 Naval Close-In Weapon System. The H/PJ-17 is a naval close-in weapon system mounted on modern Chinese warships. It is designed to defend ships against incoming anti-ship missiles, aircraft, and drones during the final seconds before impact. This system serves as the last protective layer when longer-range defenses fail to stop a threat. The weapon uses a 30mm 7-barrel rotary cannon. The rotating barrel design allows a very high rate of fire. It can release thousands of rounds per minute. This high firing rate creates a dense stream of projectiles in front of the ship. The goal is to intercept and destroy or disable incoming threats before they reach the hull. The system is installed on advanced vessels such as the Type 055 cruiser and the Type 052D destroyer. These ships rely on layered defense. Long-range missiles engage threats at distance. Medium-range systems provide additional coverage. The close-in weapon system handles targets that penetrate those outer layers. Targeting is radar-guided. The system uses onboard sensors to detect, track, and calculate the speed and direction of incoming objects. Once locked, the fire control system automatically directs the cannon. Reaction time is extremely short because threats at close range leave only seconds for response. Compared to the American Phalanx close-in weapon system, the H/PJ-17 uses a larger caliber round. The Phalanx system uses 20mm ammunition. Both systems serve the same defensive role, but differences exist in design and ammunition size. Each reflects the doctrine and engineering choices of its navy. In modern naval warfare, missile attacks can occur at very high speeds. A reliable, close-range defense system is essential for ship survival. Close-range defense is critical, but what if the real threat never appears on radar at all? Number 4. Beidou Military Satellite Navigation and Anti-Satellite Capability. The Beidou system is China's independent satellite navigation network. It provides positioning, navigation, and timing services similar to the American GPS system. Unlike GPS, which is operated by the United States, Beidou is fully controlled by China. This independence ensures that military operations do not rely on foreign satellite signals. For military use, Beidou offers high-precision positioning. Accurate location data is essential for missile guidance, aircraft navigation, naval coordination, and ground troop movement. Precision targeting improves strike accuracy and reduces dependence on older guidance methods. The system supports encrypted military signals that are more secure and resistant to interference than civilian versions. Satellite navigation also supports battlefield coordination. Units on land, at sea, and in the air can synchronize movements using shared positioning data. Timing signals are important for communications, networks, and command systems. Modern weapons often rely on satellite guidance to reach designated targets accurately. China has also demonstrated anti-satellite capability. In 2007, it conducted a test that destroyed one of its own weather satellites using a ground-launched missile. The test showed that China could target objects in orbit. This event highlighted the vulnerability of satellites in modern warfare. Space-based systems increase missile accuracy by providing reliable coordinates. They also allow real-time updates and tracking in some cases. To prepare for possible space conflict, redundancy measures are important. These can include multiple satellites in orbit, alternative guidance methods, and ground-based backups. Control of space assets plays a major role in modern military operations. Navigation satellites connect strategy, technology, and precision in a single network. But precision targeting from space means nothing without soldiers on the ground equipped to use it. Number 3. QTS-11 Integrated Combat System. The QTS-11 is an advanced infantry weapon system developed for the Chinese military. It combines two weapons into one integrated platform. The first component is a 5.8mm assault rifle. The second component is a 20mm grenade launcher mounted above the rifle barrel. These two systems are connected through a shared electronic fire control unit. The rifle portion fires standard small-caliber ammunition used by Chinese infantry forces. It provides automatic and semi-automatic fire for regular engagements. The upper launcher is designed to fire programmable grenades. These grenades can detonate in the air at a calculated distance, rather than only exploding on impact. A key feature of the QTS-11 is its integrated ballistic computer. This computer works together with a built-in laser rangefinder. When the operator identifies a target, the rangefinder measures the exact distance. The ballistic computer then calculates trajectory, angle, and timing. If the operator selects airburst mode, the system programs the grenade to explode at a specific point in space. This allows the grenade to detonate above or near a target, rather than directly hitting it. Airburst capability is especially relevant in urban combat environments. In cities, opponents may take cover behind walls, inside rooms, or behind vehicles. A grenade that detonates at a calculated position can increase effectiveness against targets in covered positions. This does not make obstacles irrelevant, but it changes engagement tactics. The system allows more precise use of explosive rounds in confined spaces. The QTS-11 also integrates optical sights and digital displays. The fire control system helps adjust for distance and environmental factors. While wind and weather still affect projectile travel, electronic calculation improves first shot probability compared to traditional grenade launchers. Development of the QTS-11 reflects earlier international attempts to combine rifles with programmable grenade systems. The United States worked on the XM-29 Objective Individual Combat Weapon program in the 1990s and early 2000s. That project aimed to combine a rifle and airburst launcher in one system. However, the American program faced technical challenges related to weight, cost, and reliability, and it was eventually canceled. China continued its own research path and fielded the QTS-11 in limited numbers with specialized units before broader introduction. The QTS-11 is heavier than a standard assault rifle due to its electronics and dual-barrel configuration. Because of this, it is typically assigned to specific roles rather than replacing all infantry rifles. Its value lies in integrating precision calculation with explosive capability at the squad level. This system represents a shift toward digitally assisted infantry weapons that combine computing and firepower in a single platform. Infantry weapons are evolving, but China's battlefield is not only physical, it is also digital. Number 2. Strategic Cyber Warfare Units, PLA Strategic Support Force. In 2015, China reorganized part of its military structure and established the Strategic Support Force. This branch was created to centralize capabilities related to cyber operations, electronic warfare, and space systems. Instead of keeping these functions separate, the new structure combined them under unified command. The goal was to improve coordination across different technical domains. Cyber operations form a major part of this force. Cyber reconnaissance involves gathering information from foreign computer networks. This can include mapping systems, identifying vulnerabilities, and collecting strategic data. Cyber units may attempt to access sensitive systems for intelligence purposes. Such operations do not always involve visible disruption. Often, the focus is on long-term access and data extraction. Network disruption is another capability. In a conflict scenario, cyber units could attempt to interfere with communication systems, logistics software, or command networks. Disruption can range from slowing systems to temporarily disabling them. Modern military forces rely heavily on digital networks for coordination. Interference in these systems can affect operational efficiency. The Strategic Support Force also handles electronic warfare. Electronic warfare includes jamming radar, interfering with communications, and protecting friendly signals from interference. Control of the electromagnetic spectrum is essential for aircraft, ships, and ground forces. Electronic systems can influence how well sensors and weapons perform. Space operations are integrated within the same structure. Satellites support navigation, communication, and reconnaissance. Protecting these assets and understanding potential vulnerabilities in foreign space systems are part of strategic planning. Several cyber espionage cases over the past decade have been linked by foreign governments to groups associated with the Chinese military. These cases have involved alleged intrusions into corporate networks, defense contractors, and research institutions. Attribution in cyberspace can be complex, but investigations have repeatedly identified patterns connected to Chinese-linked actors. Integration with conventional operations is a defining feature of the Strategic Support Force. Cyber and electronic actions are not treated as isolated events. Instead, they are coordinated with naval, air, and ground operations. For example, Cyber reconnaissance could precede physical military exercises. Electronic warfare support could accompany naval deployments. Information warfare doctrine also plays a role. This includes controlling narratives, protecting domestic information space, and shaping perceptions during crises. Information control and digital messaging are considered part of modern strategic competition. The creation of a dedicated force for cyber, space, and electronic domains shows how military power now extends beyond traditional weapons. Modern conflicts involve data, signals, and networks as much as ships and missiles, and yet, even cyber operations pale in comparison to the weapon that may redefine naval warfare entirely. Number 1. Fujian Aircraft Carrier, Type 003, with electromagnetic launch system. The Fujian Aircraft Carrier, also known as Type 003, is the most advanced aircraft carrier built by China to date. It represents a major step forward in Chinese naval engineering and carrier design. Unlike China's earlier carriers, Liaoning and Shandong, the Fujian was designed and constructed domestically from the beginning as a larger and more capable platform. One of its most important features is the use of an electromagnetic aircraft launch system, often referred to as EMALS. This system replaces the traditional ski jump ramp that was used on China's previous carriers. A ski jump launch system relies on the aircraft's own engine power to take off with assistance from an upward curved ramp. While effective, this method limits the maximum takeoff weight of the aircraft. Heavier aircraft cannot launch with full fuel and payload using only a ski jump. The electromagnetic launch system works differently. It uses electrical energy to accelerate aircraft along a flat deck track. Instead of steam catapults, which are used on some foreign carriers, the Fujian uses electromagnetic force to generate smooth and powerful acceleration. This allows aircraft to take off with greater weight. Heavier aircraft can carry more fuel, more weapons, or additional equipment. This expands operational flexibility. The Fujian has a significantly larger displacement compared to Liaoning and Shandong. Estimates place it above 80,000 tons, making it closer in size to large modern carriers used by other major naval powers. A larger displacement allows for a wider flight deck, increased internal storage, and improved aircraft handling space. More deck space supports efficient movement of aircraft between hangar and launch positions. Another technical advantage of electromagnetic launch systems is improved sortie generation rate. Sortie generation rate refers to how many aircraft missions can be launched and recovered within a given time. EMALS systems can reset more quickly between launches compared to older steam systems. This allows for smoother flight deck operations and potentially higher launch frequency during sustained operations. The Fujian also reflects growth in China's indigenous shipbuilding capacity. Building a carrier of this scale requires advanced metallurgy, precision engineering, complex electrical systems, and integration of radar and command networks. The development of EMALS technology domestically demonstrates progress in high-power electrical generation and control systems. Carrier construction of this size requires coordination across multiple industrial sectors, including propulsion, aviation support, electronics, and weapons integration. Unlike earlier carriers that were modified from older designs, the Fujian was purpose-built with a flat deck configuration optimized for catapult launches. This layout allows it to support a wider range of aircraft types, including fixed-wing early warning aircraft that require catapult assistance for takeoff. The Fujian aircraft carrier stands as China's most advanced naval platform. It combines size, electrical launch capability, and modern design in a single vessel. Its construction marks a significant milestone in China's naval development and industrial capacity. China has built a defense system that covers land, sea, air, space, and even cyberspace. These weapons show careful planning and strong preparation. Any nation that underestimates this level of readiness would face serious resistance. With this range of technology and coordination, China stands alert, equipped, and fully prepared. If you enjoyed this video, like and subscribe, and also click the next video shown on your screen.